Welcome to Brico Industries. We would like to invite you to join us on a brief picture tour of our manufacturing facility as we demonstrate the processes involved in the manufacturing of quality fasteners. The variety of externally threaded fasteners used in industry today is virtually unlimited, and the number of operations available to produce these items is also unlimited. We would like to cover the basic operations that are required to manufacture the majority of quality screws used in industry. There are many things involved in the manufacturing of externally threaded fasteners. It all starts with the raw material here in the wire room. There are a wide variety and types of cold heading wire used in the making of fasteners. At Brico, we use only top quality, mill-certified cold heading wire for each product we manufacture. We use both symbols and color coding in identifying our raw materials. We use cold-headed quality steel, stainless steel, aluminum, brass, and silicon bronze. We also run several additional materials that may be specified by our customers. Our short tour will show you the transformation from wire to a completed quality fastener. A quality product requires quality built in from the start. This demands quality tooling. A finished item will only be as good as the tooling used in manufacturing it. To maintain consistent quality requires the operator to change his tooling at the proper time. Excessive wear on tooling will not provide a consistent quality item. The cold-headed process involves a series of die cavities and punches which will reshape the wire into the required form. The header die is held in a block and the wire is transferred into the die cavity. Each cold-headed blank has a specific set of tools for each configuration required. We are looking at a cutter and a quill which cuts the exact amount of material required for the blank being formed. The next view is the first blow or upset punch that starts the initial forming. The final punch can contain the drive system such as a hex form or a Phillips recess. This is an example of 3 finishing punches. The Quadrex drive punch is on the right, the Phillips drive is in the middle, and the hex pin on the left. To maintain a quality finished product requires us to maintain wire consistency throughout the manufacturing process. This entails using a process that ensures absolute lot integrity and full traceability all the way back to the original material heat melt. Our process assures that this will always happen. Wire can be used in different forms, in exact finished sizes that go directly into the die cavity, or it can be drawn from larger sizes. There are situations when it is advantageous to draw wire to a specific size immediately prior to insertion into the die cavity. At these times, we use a wire drawer such as you see here. Different materials and/or some head configurations may also require the use of another device called a wire heater to aid in the formation of the final shape of the head. Heat causes the wire to become more malleable, thus it will flow easier. Let's take a look at what is happening in the cold header at this time. This is a little too fast to really see what is happening, so we are going to slow down the process to enable you to get a better view. The wire is fed into the cutoff area of the header by the feed rolls. The feed rolls will put the wire up to the wire stop, which is set to provide us with enough material for the exact length required for the screw blank being made. As soon as the wire is cut off, it is transferred over to the die area and is inserted into the die cavity. For most fasteners, we use 2 forming blows that will provide us with the required head configuration. The first blow or upset blow is designed for a specific part or head style. The second blow or finishing punch forms the part's final head configuration. If a recessed drive is required, the second blow provides the drive as well as the final head shape. Large multi-die parts formers which use a cold heading process may run as slow as 50 pieces a minute. Other specialty high-speed parts formers will approach speeds of up to 1,000 pieces a minute. The complexity, material, and the size of the parts involved determine the speeds as well as the type of machinery used in manufacture of cold-headed items. The cold-headed process alters the flow of the grain of the product. This results in a much stronger item being formed than those items being made on a screw machine, which cuts away material. The cold forming operation eliminates scrap. providing you with the advantage of maximum use of your raw material and a product with superior strength. We now have a precision blank available for further processing. Some screws require a screwdriver slot for ease of assembly and service. To accomplish this, we use metal cutting saw blades which cut the slot one blank at a time on a circular rotating dial. The head slotting operation is the second step in the process flow of a finished fastener. After head slotting, the next normal step is to have threads rolled on the blank by the thread rolling process. Thread rolling is a high-speed operation as evidenced by these hot screws coming off the thread roller. We get from headed blank to the finished screw through the use of a pair of roller dies. The threads are formed by displacing material to form the finished thread crest at speeds approaching 500 pieces per minute. Each blank is individually pushed into the start of the die by a mechanical finger. From the starting point in the roll die, the blank rotates or rolls through the entire length of the roller dies. This produces increased pressure on the blank and forces material into the desired thread crest. Another common operation in the manufacture of screws is a shank slot process. This is used in the production of thread cutting screws, which are used to cut their own threads as they are inserted into the mating part. This is also done by using metal cutting saw blades. There are additional operations that can satisfy specific requirements of the end user or customer, such as shaving a special area or pinching a special point on the screw. Trimming, drilling, and tapping are also available upon request. With the high speeds and the wear inherent in the coal heading manufacturing process, it is imperative that we do constant, regularly scheduled maintenance, including complete rebuilding of the machines to maintain a quality product. The rigid specifications and high-speed production required in our product leave no room for poorly maintained equipment. Periodically, the machines are removed from the production line and taken down to the basic frame for a complete rebuilding and upgrading. Now let's look at what we have seen, the wire cutoff to the finished product. We have put together this tour primarily as a source of information to help increase your knowledge of the manufacturing process of the common screw. Obviously, we have tried to keep our focus very specific, but we would like to add that there is a lot of support and staff necessary to produce a quality fastener. We hope this has been informative and helps your understanding of the processes used in a modern coal heading manufacturing company.